This is the video tutorial for the confocal imaging using the confocal microscope. Please refer to the fluorescent imaging tutorial to get the sample in focus. Before imaging, make sure the lights are turned off. Double-click the EZC1 3.91 icon on the desktop to open up the confocal software. The menu that appears allows users to set up and manage individual profiles suited to their preferences. Once in the software, it is necessary to locate the laser power control bar. If it does not appear on the screen, it can be located in the Tools menu at the top of the screen. All other necessary control tools can be found in this menu as well. Individual windows can be viewed as a single color or a tile view. The tile view button can be found at the top toolbar. Individual colors can be seen by clicking the 2D window and selecting which colors to be viewed in this window. If more than one windows are desired, the new window button can be found here. In the upper right hand corner, select the objective currently being used. This ensures proper calibration in sizing and measuring. On the laser power control bar, select the intensity for each laser used. Generally, it is better to use a lower laser power. This will reduce the amount of photo bleaching. However, if an image is unable to be seen due to low signal intensity, a higher laser power will increase the brightness. If the laser power exceeds 30% without producing an image, there is something flawed in the way the sample was stained. Next, in the box to the right, select which lasers to excite the samples with and which detectors to use. This should correspond to the dye or dyes used to stain the sample. If more than one type of dye was used, it is more advantageous to use the frame lambda option. This option allows multiple passes at the sample with a single laser and detector. This will significantly reduce the amount of bleeding that happens when two lasers are simultaneously fired at the sample. Under the Frame Lambda tab, set up the desired laser and detector used in that pass. Click the Preview Pass box and select the pass. This will allow you to optimize the settings for each pass. Make sure the Frame Lambda green square is selected and push Live. Live is a fast scanning mode that essentially allows you to view the image in real time. Single takes a single shot of the image. Normal and bidirectional are the different ways the laser will scan the image. In normal, the laser will start at the top left corner, scan across and move down 1 pixel and scan that line. In bidirectional, the laser will simultaneously scan from top and bottom. A fast live scan is produced, however the quality will be compromised. Normal is the desired scan speed. Now start bringing up the gain until an image appears. Every pixel on the screen is associated with an intensity number between 0 and 4095. These are points of saturation where the pixel is outside the intensity range. Adjust the gain so that the image is just under the saturation level. Where the gain intensifies bright colors, offset makes dark spots darker. This option will be left unused. Optimize the gain for each pass that is set up. Pinhole can be changed from this drop-down menu. The larger the pinhole, the brighter the image will be. Making the pinhole smaller will make the image more crisp and sharp. Medium is used most frequently. The average option allows you to reduce the amount of noise in the sample. This will tell the microscope to take 2 or more images and average the pictures together to obtain a crisper image. The Z option is covered in a separate Z-Stack tutorial video. Pixel dwell option will also reduce the amount of noise in the image. By increasing pixel dwell, the laser will excite each pixel on the screen for a longer period of time, intensifying the color of the image as well as reducing noise. Note that increasing pixel dwell will also alter the gain and increase photo bleaching. Once the image is optimized, turn off the live scan. Select 1024 pixels. This will increase the resolution of the image, however take a longer time to take an image. Generally, when the image is in live scan, 512 pixels is chosen to make the scan quicker, and 1024 pixels or 2056 pixels are for higher resolution pictures. Make sure Preview Pass is unselected in Frame Lambda, and the green squares next to Average and Frame Lambda are selected. Click Single. After the image is taken, the tile view will show each channel on the screen, and a separate window will show the overlay between all windows. Top right corner, there's an image of a cube. Click on the cube and it will bring you to a window containing the image. Click to drag or rotate the dotted square in the window. This will select a specific area in the picture to be image. It operates similar to an artificial zoom. However, the field of view will be lost in this way. To zoom out, drag the scroll bar next to the field zoom back to 1x. Click on the ruler icon in the upper toolbar. Click on the image to draw a scale bar. You can change the properties of the scale bar by right-clicking and selecting the Properties option. Note: the scale bar will be incorrect if the correct objective is not selected. Save both tile and average images in the appropriate folders. File should always be in a .ids file format, which is the native format to the confocal software.